Good morning, everyone. Good morning, panels. Our advisors, we are your presenters, and this is our thesis entitled "The Assessment of Water Quality in the Zao Mountain Community in the River in Balotao in Pasugong, Bukidnon." For the background of the study, the freshwater ecosystem, such as the rivers and the streams, are an important factor in maintaining ecological balance and sustaining biodiversity. These ecosystems not only provide habitats for various aquatic insect organisms, but also serve as an essential resource for human communities. However, the human improper waste management affects the water quality in many of these freshwater ecosystems, which leads to water degradations. And water degradation not only affects human health, but also impacts aquatic life, including the zooplankton. The zooplanktons are microscopic organisms which are crucial for monitoring the quality of water, pollution, and also state of eutrophication. And their small size makes them vulnerable particularly to environmental changes as they respond quickly to changes in water temperature, conductivity, and also nutrients. Due to their sensitivity to environmental fluctuations, traffic conditions, and pollution levels, zooplanktons are widely recognized and affected by indicators providing crucial insight into the ecological status and changes in aquatic ecosystems. The Dila River is located in the Dila River is located in Balotao in Pasugong Bukidnon, and over time, the status of the Dila River has visibly declined due to increasing water pollution. Despite the alarming degradation of the Dila River, no studies have been done to assess the water quality and the zooplankton community in this area. And this study aims to assess the water quality and the assessment and identification of the zooplankton species in the river, which can provide valuable information necessary to support sustainable water development of these river ecosystems. The objectives of our study is to evaluate the water quality in the Dila River based on the physical-chemical parameters such as temperature, dissolved oxygen, biochemical oxygen demand, total suspended solids, and conductivity. Also, to identify the zooplankton species in the River and to determine the diversity of the zooplankton found in the study site, and lastly, to evaluate the relationship between the zooplankton community structure and water quality in the River in Palatay, Pasagong, Bukidnon. For the significance of our study, the results would be beneficial to the following groups of people and will have the following purposes. For the LGU, our study can serve as a data for water management policies. For the environmental agencies, our study can become a basis for conservation. For the researchers and academics, our study can be added to the freshwater ecology knowledge, and for the local community, it can inform locals about the current status of the river. For the conservation organizations, our study can support initiatives for the students and educators. It can help them for their educational purposes. For the scope of our our study focused only on the River in Palagay, Pasig, Bukidnon, and it uncovered the assessment of water quality using the physical chemical parameters and analysis of the zooplankton community. The sampling was conducted using the three sections, the upstream, the midstream, and downstream, and study was conducted over 3 months from October to November and December 2025. For the limitations, our study did not include the seasonal variation in water quality or the zooplankton compositions. Another aquatic organisms are not assessed, such as the macroinvertebrates and phytoplankton, and also fishes. Also, our study is limited to observable and measurable water parameters and morphological identification of the zooplankton community only.
So, good day everyone. I will now present the chapter 3 of our thesis, which focuses on the methodology used in the assessment of the water quality and the zooplankton community in Dila River, which is located in Barangay Impalutao in Pasugong, Bukidnon. This chapter outlines the entry protocol, research setting, research design, the safety procedure, sampling procedure, collection of water samples, analysis of the physical-chemical parameters, the water quality index, zooplankton collection, identification and quantification of the zooplankton, the diversity index, the method of analysis, the ethical consideration, and the documentation. Next, please. So before conducting the study, we secured all the necessary consents and permit in which formal letters requesting consent was submitted to the barangay captain of Barangay Impalutao, the office of the mayor of Impasugong, and the DENR Region 10 in Cagayan de Oro City. These approvals granted as these approvals granted us a gratuitous permit allowing us to legally collect water samples and assess the water quality and zooplankton community of Dila River. This ensured that our study complied with the local government and environmental regulations. Next. The study was conducted in Dila River located in Barangay Impalutang, the municipality of Impasugong and the province of Bukidnon. The river is approximately 7 kilometers long and characterized by mountainous and forested landscapes. It extends from Sitio Kibua, which serves as the upstream station, down to the Dila Falls, our downstream reference point. We established three sampling stations, which is the upstream, midstream, and the downstream stations. Sampling was conducted from October to December 2025. Water samples were analyzed for physicochemical parameters, while zooplankton samples underwent morphological identification and quantification using standard taxonomical keys. Next. Next. So for the research design, the study used a quantitative research design. The main objective was to assess the physicochemical parameters of water, to identify and quantify the zooplankton species, to determine the relationship between the water quality and zooplankton diversity. Next. For the safety procedure, safety was a priority during the field and laboratory works. During sampling, we wore closed-toe boots to prevent slipping. Long pants and high visibility clothing were used. Nitrile gloves were worn to avoid direct contact with contaminated water. Safety goggles protected us against splashes, and personal flotation devices like the the life vests were required in deeper or fast-moving areas. In the laboratory, we use chemical resistance gloves, face masks, and splash goggles. Next. For the sampling procedure, we used a stratified random sampling method in which the river was divided into three stations based on water current intensity. Next. Which we have the upstream, which has a fast current near a residential areas with slight anthropogenic influence. Next. The midstream, which had a moderate flow, rocky substrates with riparian vegetation. Next. Downstream, which has a slow flow, deeper water, and dense forested vegetation. Next. For the collection of water samples was collected from 8 a.m. to 12 p.m. over 3 period of months. During the collection of water samples, the bottles were submerged at a 0.5 meters below the surface. The bottles were tilted upwards to prevent air bubbles. No headspace was left to prevent loss of volatile compounds. The collected volumes for the water samples are 1 liter for BOD and TSS and 350 ml for temperature, DO, and conductivity. Samples for BOD and TSS were transported in an ice bag to the FAST laboratory in Cagayan de Oro City. Next. So the both physical and chemical parameters of water were measured. For the BOD and TSS, after the collection of water samples in each sampling month, the collected water samples were sent to FAST Analytical Laboratory in Cagayan de Oro City for laboratory testing and to quantify BOD, and TSS. Next. For temperature, dissolved oxygen, and conductivity, the water samples were collected in a 350 ml polyethylene bottle and brought in the Bukidnon State University Science Laboratory for measurement or testing using a calibrated micrometer and adiometer. Next. For the water quality index, it was used to determine whether the measured parameter fell within the acceptable limits for Class C freshwater bodies. The parameters included the temperature, BOD, TSS, DO, and conductivity. Each parameter was converted in an index value. We used the simple water quality index ISCA formula, in which the water quality is equals to temperature index times the sum of BOD, TSS, DO, and conductivity. The The water quality simplifies the complex data into a single value ranging from 0, which is poor, to 100, which is excellent. This makes it this makes interpretation easier for policymakers, researchers, and the general public.
Good day, everyone. I will now present the collection, starting from the collection of zooplankton to data analysis, following the sequence of zooplankton components method. Next, zooplankton samples were collected from three established stations along the La River, with where water for physicochemical analysis was also collected, which is in the upstream, midstream, and downstream with three sampling points per station. During its sampling period from October to December 2025, approximately 40 liters of water per sampling point were filtered using a bucket and poured into the plankton net with a length of 0.253 meters with 80 micrometer mesh size to concentrate zooplankton organisms. The collected samples were transferred into properly labeled 500 ml bottles and preserved using a formalin solution to maintain their structural integrity prior to laboratory examination. Next is zooplankton identification. In the laboratory, 24 random 0.5 ml of preserved samples were placed in a sensory cluster counter using an aspirator and pipette and observed under a compound microscope. Zooplanktons were identified based on morphological characteristics using standard taxonomic keys and reference material, and also measured them using a calibrated micrometer to classify them into their respective groups and species. After identification, individual organisms were counted to determine the abundance of each species per month. This allows us to see the comparison of abundance and species richness across all sampling periods from October to December, and this data were recorded on a notebook. The channel winner diversity index was computed using past software, where species abundance data per sampling period was used to determine species dominance, diversity, and evenness within the zooplankton community across sampling periods from October to December 2025. For the data of analysis, all collected data were organized, tabulated, and statistically analyzed to further examine the relationship between physicochemical parameters and zooplankton community structure. Principal component analysis or PCA was performed. PCA helped identify patterns, correlations, and the key environmental factors influencing species distribution by reducing multiple variables into principal components for clearer interpretation. For the ethical consideration, sampling was conducted responsibly to minimize ecological disturbance. Data was used with confidentiality and community transparency. Data was shared with LGU and stakeholders. For the documentation, all procedures, observations, and raw data were carefully documented using a field notebook and a mobile phone camera to ensure accuracy, transparency, and reliability of study findings. This systematic methodology allows us to see comprehensively as allow us to comprehensively assess the zooplankton community and its relationship with water quality in Dila region.
For the result, for the results and discussion, this chapter presents the key findings of the study, provides an interpretation of the results collected from the assessment of water quality and the zooplankton community in the river in Palakay, Pasagong, Bukidnon. The standards used for the classifying rivers water health are based on the Water Quality Index, which is a standard tool followed by the World Health Organization to determine the condition of the Dila River and support the analysis of its suitability for aquatic life. The physical-chemical parameters of the river, namely the temperature, dissolved oxygen, biochemical oxygen demand, total suspended solids, and conductivity, were documented from October to December and were taken from three sampling points, specifically the upstream, midstream, and downstream, to determine spatial variations in water quality of the riverine ecosystem. For the for the October data, the physical-chemical parameters of the river in the month of October showed relatively uniform temperature across the sampling points, with all stations having 24.9 degrees Celsius. This uniformity in temperature indicates that stable thermal conditions during this month during there is a stable thermal conditions during this month. In terms of biochemical oxygen demand, the present study was able to record less than 1 milligrams per liter across upstream, midstream, and downstream, and these low values of BOD generally indicate limited biodegradable organic matter, which is according to Burma and Singh in 2012. Thus implies that the river ecosystem is not heavily polluted by organic waste pollutants. However, values for dissolved oxygen were also notably low, ranging from 1.28 milligrams per liter to 1.33 milligrams per liter. This level of DO falls considerably lower than the recommended threshold for Class C freshwater bodies, implying possible organic pollutions, high microbial activity, and stagnation of water for high water temperature. According to Casais 2022, the optimal range of temperature that would support oxygen solubility in water between zero is between 0 degrees Celsius to 20 degrees Celsius. Temperature above 20 degrees Celsius may cause a decline of oxygen solubility, which results to a decrease of DO levels. This coincides with the recorded temperature during this month, which may have caused the decrease of available oxygen in the river. With these values of DO, the river is experiencing oxygen depletion, thus may not be capable of sufficiently supporting most aquatic life, particularly those oxygen depletion organisms. Moreover, this month recorded an average of 25 milligrams per liter for total suspended solids, with downstream sites showing the slightly higher values, which is 27 milligrams per liter. The values for conductivity also followed a special pattern, increasing from 81.67 and in downstream having the highest result of 100 USEM. This increasing values of TSS and conductivity in the downstream portion of the river suggest increasing turbidity and pollution toward the lower stretch of the river. This may attributed to possible soil erosion, increased rainfall, or small-scale land disturbance, which could have introduced mineral and salt pollutants, leading to higher dissolved ions in the downstream of the river. For the month of November, temperature remains stable, averaging 25 degrees Celsius. This temperature still falls within acceptable limits for tropical freshwater ecosystems. While remarkable change was observed in dissolved oxygen levels, which drastically increased with a total average of 14.9 milligrams per liter across all sites. These elevated DO values indicate excellent aerations likely influenced by increased or higher flow rate since late October and early November still falls in rainy seasons. And tropical cyclones like the Typhoon Pino and Typhoon Uwan also influence the weather of the whole Philippines, including the Bukidnon. Data from local Pagasa unit in Malaybalay also recorded an average of 205 5.8 millimeters of rainfall for the whole month of November. In terms of BOD, the values increased slightly during this month, averaging 2 milligrams per liter across all sampling points. Though this is higher than the October, it remains within acceptable limits and still suggests low to moderate organic matter in river. Total suspended solids also varied more widely, with an average of 7.1 milligrams per liter and highest results recorded downstream averaging 12 milligrams per liter. For conductivity, the values in November range from 81.67 to 100 US per centimeter, showing similar spatial pattern to the previous month, having lower conductivity in upstream and progress to higher values in downstream. However, the values of TSS and conductivity during this month is significantly lower than in October, which implies minimal environmental disturbance and pollution during this period. For the month of December, temperatures slightly increased, ranging 25.1 to 25.4 degrees Celsius, but remained within the optimal range for tropical freshwater organisms and within acceptable limits for tropical freshwater ecosystems. Dissolved oxygen concentrations remained high, ranging from 15 to 16.1 milligrams per liter, which indicates sustained favorable conditions for aquatic life. High DO values during this period may also be attributed to the increased flow rate of the river, thereby enhancing oxygen diffusion. Local Pag-asa unit have recorded a remarkable total rainfall in the previous month, which is November, which is a total of 205.8 millimeters, which may have possibly contributed to the increase of the flow rate in the La River during the sampling period in early December. The biochemical oxygen demand during this month has an average value of 3.10 milligrams per liter, with the upstream having the highest average of 4.7 milligrams per liter. This high biochemical oxygen demand in the upstream is likely linked to the presence of more organic matters, which may come to domestic wastewater and organic debris from nearby houses. Midstream and downstream stations, on the other hand, recorded less than 1 milligrams per liter and 2.3 milligrams per liter respectively. This indicates that the river can recover as it flows away from the residential areas and mixes with cleaner water, since tributary streams are also visible near the point. Elevated BOD in the upstream may indicate the localized organic inputs in the portion of the river, while lower midstream values suggest effective self-purification processes. The total suspended solids range from 3.7 to 4 to 11 milligrams per liter, with the highest value recorded in downstream. And this suggests that the sedimentary suspension and accumulation in downstream areas, potentially intensified by increased discharge conductivity, on the other hand, exhibited a notable increase at downstream, averaging 202 per centimeter, which is significantly higher than the other sampling stations. And this elevated conductivity in the downstream may indicate localized inputs of dissolved solids from water runoff or anthropogenic activities surrounding the area.
Water temperature in Dila River remained relatively stable from October to December, with values ranging from 24.7 degrees Celsius to 25.4 degrees Celsius, and a slight increase observed in December, averaging 25.4 degrees Celsius. This temperature falls within the optimal range of 25 degrees Celsius to 30 degrees Celsius for freshwater bodies and are classified as good based on the WQI and Dow standards. The consistency of temperature across sampling stations indicates minimal thermal disturbance and an absence of thermal pollution. Overall, the stable temperature conditions suggest a favorable and supportive environment for aquatic organisms in the river. The dissolved oxygen levels in Dila River show a marked increase from October to December. In October, DO values range from 1.28 to 1.33 mg per liter, which were below the minimum standard of 5 milligrams per liter set by the WQI and Dow guidelines, indicating poor oxygen conditions during that month. However, DO concentration significantly increased in November with 14.8 to 15 milligrams per liter and remained consistently high in December with 15 to 16.1 milligrams per liter, meeting and exceeding the required standard for freshwater bodies. And according to Pag-asa 2025 and Alan and Castillo 2007, this substantial improvement suggests enhanced aeration and reduced hypoxic stress in the latter months, likely influenced by seasonal hydrological changes such as heavy rainfall and tropical cyclones that occur during the study period. Bio- Biochemical oxygen demand in Dila River show a gradual increasing trend from October to December, particularly at the upstream station. During October and November, DOD values across all stations range from less than 1 milligram per liter to 2 milligram per liter, indicating low organic matter present, while in December, values range from less than 1 milligram per liter to 4.7 milligram per liter, with the highest concentration observed upstream. Despite this increase, DOD levels remain within the acceptable limit of 7 milligrams per liter for surface water, suggesting low to moderate organic pollution. Overall, the results indicate that the river maintains a good to fairly good water quality and retains its natural capacity for self-purification as it flows downstream. Total suspended solid values in Dila River from October to December range from 2.3 milligrams per liter to 27 milligrams per liter, with the highest concentration consistently recorded in October. The elevated TSS levels during this month may be attributed to increased rainfall intensity, which enhanced soil erosion, bank scoring, and resuspension of bottom sediment, contributing to higher sediment transport dynamics. This pattern aligns with a common effect of runoff and erosion in river systems during hydrological events, and that is according to DENR 2016. Despite these fluctuations, all recorded TSS values remain within the permissible limit set by the DENR DAO guidelines and were classified as acceptable under WQI standards, indicating that the suspended solids did not significantly impair the ecological conditions of the river during the study period. Conductivity values in Dila River increased from October to December, with the highest value of 202 microsiemens per centimeter recorded at a downstream station in November. Overall, conductivity ranged from 81.67 to 202 microsiemens per centimeter, indicating normal ionic concentration for freshwater system, although the elevated downstream value suggests localized imports of dissolved solids, possibly from surface runoff. The spatial variation reflects differences in dissolved ions concentrations influenced by environmental factors along the river course. Despite the increase, all recorded conductivity values remain within the excellent classification of less than 250 microsiemens per centimeter under WQI standard. And although Dow does not set specific limits for conductivity, it is recognized as an important indicator of dissolved ions in water quality assessment.
So this table presents the average physicochemical parameter baliksa parameter of Dila River from upstream, midstream, and downstream station during October, November, and December 2025 compared with water quality and DNR DAO standards. Next. In October, the water quality index ranges from 72 to 74, classified as good. Temperature, BOD, and TSS and conductivity were all within the acceptable standards. However, dissolved oxygen was low, ranging from 1.28 to 1.33 milligram per liter, which is below the required less than or equal to 5 milligram per liter. Despite this, the overall water quality index remained good due to favorable results from the other parameters. Next. In November, water quality significantly improved. The water quality increased to 95 to 97, classified as excellent. Dissolved oxygen rose to about 15 milligrams per liter. BOD remained low and TSS decreased. These results indicates improved oxygenation and lower suspended materials in the river. Next. In December, water quality index values range from 90 to 95, still within the excellent category. Dissolved oxygen further increased, BOD remained within the standards, and conductivity, although higher is in downstream, was still within acceptable limits. The WQL values range from 72 to 95, showing improved from good in October to excellent in November and December. This indicates that the Dila River maintained favorable physicochemical condition with low pollution levels and limited anthropogenic disturbances during the study period.
So, for the identification of zooplankton species in the river in Planetary Pascal Mukidna. So, a total of 10 zooplankton species classified under 10 genera were documented in the La River, namely the Acarsiotanza, Anuropsis sp, Bosminia fetalis, Frankinus sp, Keratella valga, Licani limata, Lepadella biloba, Platius quadricornis, Iridiolarian, and Thermocyclops crassus. The zooplankton genus uh, gen- the zooplankton genus and species were identified based on external morphological features and body measurements observed under light microscopy. Identification was carried out using the established taxonomy keys and descriptions provided by Shell in 1995, Seegers, Papa, Bueno, Inchman and Hindner, Horn and Goldman, Riazo, and Mamaril and Kujamar, which are widely used for freshwater zooplankton identification and tropical water systems. For the species 1, Acarsiotonza then. Acarsiotonza, now pili in these figures, represents the earliest free-swimming larval form that hatches from the fertilized egg. The nucleus body is simple and unsegmented, consisting primarily of a prominent head region that bears the three pairs of primary larval appendages, antennules, antennae, and mandibles, which are used for locomotion and internal feeding. Initial feeding. A copepod nucleus, it lacks the fully delineated thoracic and abdominal segmentation seen in later copepods and adult stages. Instead, the body is more oval to nearly cylindrical with a median nuclear eye located centrally on the head that functions in like directions during early development. The appendage, the appendage are fringed with setae that aid in both swimming through the water and column and sit, ano to? Column and generating feeding currents to capture microplanktonic prey. Acacia thomsonii demonstrate a clear morphological distinction from juvenile and adults, with the latter exhibiting additional body segmentation and uh, more complex locomotory or feeding appendage absent in the nuclear form. Next is the Anuropsis sp. Anuropsis sp are small planktonic monogonal frutifers characterized by compact, rigid lorica that generally obey the boat shape and dorsoventrally flattened. The lorica surface is often finely punctured or smooth and lacks long posterior spines, which distinguishes this genus from many other branchiodontifers. A key diagnostic feature of Anuropsis species is the presence of the distinct anterior sinus or notch at the head margin, typically U-shaped, which may bear small external teeth or projections. The body is widest at the mid-region, giving the organism stocky appearance on the posterior, and is usually rounded or slightly truncated without a well-developed foot. For our species 3 is a Bosmina fatalis. Mar- Bosmina fatalis is a small planktonic cladoceran crustaceans in the family Bosminidae, characterized by a laterally compressed carapace that encloses most of the body, giving it an almost rounded or oblate appearance in the side view and providing protection while swimming in the water column. The head region is relatively large and rectangular, with no shape demarcation between head and body dorsally, and it bears single small compound eye near the base of forward projecting rostrum. A distinctive, a distinctive morphological trait of Busmina fatalis is the immobile antennae fused with the rostrum, often showing a slight concavity in their junctions, and the antennules typically carrying characteristic pointed projections along the midlines that can help differentiate Busmina fatalis from other Busmina species. Treatment. Seasonal studies of Busmina fatalis and related species have shown that these species can exhibit morphological plasticity with features of elongated antennules and mouth rows becoming more pronounced under high collision pressure from invertebrate predators such as Leptodora kibti, indicating adaptive cyclomorphic changes in body form. For our species 4, the Branchynus sp. followed are planktonic monogon first characterized by a rigid outer covering called lorica, which is typically oval to rectangular in shape and may be smooth or ornamented depending on the species. The lorica is often divided into dorsal and ventral plates and commonly bears anterior spines that vary in number and length among species, serving as protection against predators and as taxonomic characters. The anterior margins of the lorica usually possess median and lateral spines, while the posterior region contains a foot opening through which reticulate foot emerges, where the foot emerges. Nagkakunis ko eh. Keratolovalga is a loricate planktonic vertebrate in the family Branchinidae, characterized by an oval to broadly ovate lorica that is typically broader at the anterior and tapers toward the posterior, a feature that helps distinguish it from other Keratilla species with more uniformly shaped bodies. The lorica is ornamented with a rectangular and punctuate surface pattern, particularly on the dorsal plate, that bears several anterior spines that may vary in length and prominence among individuals. A defining characteristic of Kertal valga is its pair of posterior spines, which are often unequal in length, with the right posterior spines typically longer than the left, although specimens may exhibit variability, including forms with only one spine, with both spines reduced absent under certain environmental conditions.
The sixth identified zooplankton for the study is the Licani hamata. It is an ovate, dorsally compressed body. Anterior head aperture has a concave dorsal margin and a deep V-shaped ventral sinus. It has a short foot with slender, pointed toes, lacks prominent dorsal spine, with a total length of 124.63 micrometer and maximum width with 56.65 micrometer. As what we can observe in the picture from picture A, it characterized with lorica, head, sinus, trunk, and foot. Next. The seventh identified zooplankton was the Lepadilla ovalis, which is a flat ovate lorica forming a flattened profile. Anterior margins show a U-shaped dorsal sinus and deep ventral sinus. It possesses a three-segmented one 31 micrometer in width. As what you can see in the picture, it's characterized with lorica, head, sinus, collar, the trunk, and the foot. Next, the eighth identified zooplankton was the Cathias quadricornis, which is which is characterized with a prominent lorica dorsal spine with two anterior and two posterior quadricornes, and also it has a posterior foot opening and a wide head aperture from which the corona emerged, with a total length of 111.15 micrometer and with a width of 90.95 micrometer. The ninth identified zooplankton was the Radiolaria, which is a unicellular marine protozoan with a siliceous skeleton. Skeleton is intricately ornamented with spores, and the cell body is spherical or ovoid, with a total length of 203.24 micrometer and with a maximum width of 158 to 0.62 micrometer. And lastly, the Thermocyclocrassus is a copepod with a short, stout body, caudal forked twice as long as wide with setae, with long genital sumitae, and swimming legs, and antennules show diagnostic ornamentation patterns. The antennules' first antenna segmented bears are very narrow, with a total length of 895.07 micrometer and with a maximum width of 390.55 micrometer.